Hello and welcome to a screencast about seasons. In this screencast we're going to use this animation. Over here you'll see Earth in its orbit around the Sun and the tilt of the axes. Over here in the right upper hand corner you're going to see an observer, and we can move him around like this. And down here in this box you'll see the angle of insolation, or the angle of the sun's rays that the observer is looking at. Actually, you should never look into the sun. So he's not actually looking at, and I think it's a him, not actually looking at the sun's rays, but the sun's rays as they would be on any particular date. These will change as the animation runs through each season. Okay, so let's get started. Here, Earth is experiencing, well, the northern hemisphere is experiencing winter. We can see this because the northern axis is tilted away from the sun, and the southern hemisphere is tilted towards the sun. So on this date, you can see the Earth is tilted at an angle of 23.5 degrees. Therefore, 23.5 degrees south is getting the most direct sunlight. So if my observer here were located at 23.5 degrees south, you can see that the angle of insolation would be directly overhead for them because the northern hemisphere is tilted away from the sun. And as you know, 23.5 degrees south is the Tropic of Capricorn. This would be winter for the northern hemisphere. Now when we refer to seasons, we're only going to talk about seasons really for the northern hemisphere because most of the landmass is located in the northern hemisphere, and, well, we live in New York, and New York is in the northern hemisphere. This is December 21st, or could be December 22nd, depending on the year. On this date, the North Pole, as you can see, would experience 24 hours of darkness, and the South Pole would have 24 hours of daylight. Okay, so we're going to start the animation here, and we're going to watch the Earth revolve counterclockwise around the Sun. So the next season that would come after winter would be, that's right, spring. So here, we're going to stop the animation soon. Oh, went too far. Hold on. When the Earth is in the position here, this would be the vernal equinox. This is spring. Happens about March 21st. This is where the equator is getting the most direct sunlight. So I'm going to move my little observer to the equator to demonstrate that the equator is getting the most direct sunlight. So the sun is at the zenith for an observer located at the equator. Now it's an equinox, so as you can see here, you have equal daylight hours for every location in the world. There are 12 hours of daylight and 12 hours of nighttime. So you have the equator getting the most direct sunlight on an equinox, and you have equal daylight hours. And this is because neither the northern or southern hemisphere is tilted towards the sun. Okay, we're going to start the animation again, and I will really try not to miss the mark this time because I'm talking too much. Okay, just like magic, the Earth appears over here now. So now we have June 21st. This would be the summer solstice. The summer solstice, you have the northern hemisphere tilted towards the sun. Now the Earth is tilted at 23.5 degrees. So the Earth is, the northern hemisphere is tilted 23.5 degrees towards the sun. That's why 23.5 degrees north is getting the most direct sunlight. And I'm going to move my little observer to 23.5 degrees north, otherwise known as the Tropic of Cancer. As you can see from my observer, the rays are directly overhead. For my observer, they're at the zenith on this date because they are located at the Tropic of Cancer now. On this date, you see that the South Pole now gets 24 hours of darkness, and the North Pole gets 24 hours of daylight. Okay, I'm going to start the animation again, and I might help the animation move along. However, you can see my observer is still located at the Tropic of Cancer, Sun's rays are no longer directly overhead for the observer because the Earth is moving into the position of the autumnal equinox. There. Oh, I did it. I got it. So here, the autumnal equinox, again, it's an equinox, so the equator is getting the most direct sunlight. So I'll put my observer back to the equator. This is also known as fall, autumn. So during the autumnal equinox, the equator is getting the most direct sunlight. Again, because it's an equinox, every location has 12 hours of daylight and 12 hours of night. And neither the northern or southern hemisphere is tilted towards the sun. Finally, as the Earth revolves around the sun, it moves back into the position for the winter solstice, where the Tropic of Capricorn gets the most direct sunlight. As you can see, my observer, who's still located at the equator, has a lower angle of insolation. We could also say that it's a lower angle of incidence, lower angle of insolation, where the sun's rays are not directly overhead for my observer here, who's still at the equator. So I'm going to move him because he wants to be warm. Down here, there we go, 23.5 degrees south. Okay, well that does it for seasons, and thank you so much.